Hello students, welcome back. Our e-learning students, hopefully you watched yesterday our video ending the what is evolution notes. We've got now today some day 3 of our video lessons in unit. We can see here we have for number 1 in our Go Blue, what is biogeography? 2, what is embryology and what hints does it give us about evolution? 3, how can evolution be observed? And 4, what are vestigial structures? And what are 3 examples of them? So some of this is old, some of this is new. We'll kind of delve more into it. But we can see here, I'm going for announcement-wise, we can see here in the red, the syllabus signature is going to be due next Friday, so get that done as quickly as possible for 20 points. We've got the Facebook profile, which you guys will be submitting online. That is going to be due on the 4th, which is this Friday. Again, just simply type up your answer and submit. And then we've got the syllabus quiz, which is going to be due next Friday as well. So make sure we're getting on that, finishing those. I think most, if not all of you, have the quiz done already for our class. So, so far, so good. Also, make sure on Canvas you are all filling out and completing your attendance quizzes. You just go down to, I believe, attendance on the home page, and you'll find the date that we're on. It should be open to you on the date, and you will sign in that way so I can record your attendance in our class for that day. So yeah, but again, Mr. Campbell reporting here. We've got our questions, so let's go ahead and keep things quick and move through and discuss our Go Blue. So what is biogeography? Well, biogeography, guys, think of the word geography. Biogeography is the way in which how plants and animals are distributed in an area. So again, just as a reminder, make sure we're filling out our notebooks. Excuse the bell there. You guys are going to be filling these out. That way you can get good grades on your quizzes, use this for your quizzes, and you can get those notebook checkpoints as well, which are just as many points. So very, very important, okay? So how plants and animals are distributed in an area, how spread out they are, and that can impact the way they evolve, right? Now, number 2, what is embryology and what hints does it give us about evolution? Well, as you guys saw in the answers there, again, you should be writing down the Go Blue here. Write this down on page 5, okay? Then you're gonna answer the yellow here, right? 2, the earliest stages of an organism. Different organisms can look the same as embryos, which equals them having a common ancestor. Again, I'm gonna go fast here, so be sure to pause and record as we go along. 3, how can evolution be observed? This was the very end of yesterday's lesson. So let's check it out. It's gonna be the finch beaks, the moths changing color, and dog breeds, right? So we can literally see evolution happen very fast through those processes. We can see, just in a few hundred years, we can evolve wolves into Chihuahuas, into German Shepherds, all those different varieties of looks and breeds of dogs. They're all the same species, okay? And then lastly, what are vestigial structures and what are 3 examples of them? Those are structures that from evolution that we no longer use, and examples include tailbone, wisdom teeth, ear muscles, erector pili, and appendix that we saw from yesterday's video. Tailbone, used for structural purposes, but really no use for us today. Wisdom teeth, we had bigger jaws, could eat tougher foods back in the day. Not anymore. Ear muscles, used for knowing if predators are around. We can, some of us, very few of us, can wiggle our ears for that reason. And then we have erector pili, our hairs stand up for predators, and the appendix, again, used for digesting plants. All right, go ahead and update your table of contents to page 5, law versus theory. We'll just start that today. We won't finish it, but we will briefly start it. Okay, 3 structures are analogous, homologous, and vestigial. And we already know vestigial, so let's go to that. I can't skip that. Okay, so go ahead on page 4. Please record this down. Homologous structures, again, organ or bone that appears in different animals, demonstrating descent from a common ancestor. So essentially, what's the main idea? These animals have the same bones, the same ancestor, but their structures serve different functions. The human arm, right? The cat leg, running, movement. The whale fin for swimming. The bat wing for flying. So same ancestors, different function. think of that in regards to mammals, right? Mammals. Okay. Analogous, again, make sure you get this down. On the test, we've got to know the difference between homologous and analogous structures. Okay. Analogous structure. These are various structures in different species that have the same function but have evolved separately. So again, same function, different ancestor. Do not share a common ancestor, right? So for example, I've got insect wings, bird wings, and bat wings, right? So homologous, okay, the same ancestor, different function. Analogous, different ancestor, same function. Okay, so they do not share a common ancestor. So again, same function, different ancestor. Bat wing, insect wing, bird wing. Get the idea? Okay, and then vestigial, no need to write this down. We did it for our Go Blue. Structures that we no longer use. Let's go ahead. I have a video clip here to show that will kind of recap that a little bit for us. And again, it's your responsibility to watch the full video on your own. But here's a little glimpse of a sample of the video because I cannot play the full video on my YouTube videos. Check it out.
Let's talk about homologous structures first. So homologous structures have a similar structure, meaning their anatomy or the bone structure is similar. They have a differing function, so a wing versus an arm versus a fin, for example.
Said that earlier.
And they form from a common ancestor. So they have a common ancestor that gave them that structure. Analogous structures, on the other hand, have a differing structure, so they do not have a similar anatomy, but they do share a function. It's a similar function, so wings, fins, things like that. And they do not form from a common ancestor. So let's look at some examples of homologous structures. So the arm of the monkey and the fin of a narwhal. Those would be homologous structures because they are a similar structure but have a differing function. Again, the wing of a bat and the leg of a mouse would be.
So you guys get the idea. He'll break it down further. Again, you need to watch all of that on your own. Analogous, same function, different ancestor. Homologous, same ancestor, but now different functions. You guys understand the idea. Let's go ahead. Let's move on to our next stuff, which is a practice question. The tailbone is a prime example of a vestigial structure. A, true, B, false. You all know this. You should get this. It's A, true. A, true. We got it. All of the following are homologous structures to one another. This is a little trickier one, little tougher question. Are homologous structures to one another except which? A, frog arm, B, dragonfly wing, C, whale fin, or D, human hand. So which one is not the homologous structure? Okay, it's going to be B, dragonfly wing, because the dragonfly does not share a common ancestor with frogs, whales, and humans' hands, which those have bones. The wing does not in this case. Okay, let's go ahead. On page 5 of your notebook, I need you to make a T-chart comparing and contrasting law versus theory. Okay, so one side is going to be law, other side is going to be theory. This is going to be below the Go Blue you just wrote down. Okay, and what you're going to do is using that T-chart, you're going to explain and answer the differences using this video. Oh, I already have it. So we're just going to watch a minute of this. Check it out.
Theory. Chat with a friend about an established scientific theory, and she might reply, well, that's just a theory. But a conversation about an established scientific law rarely ends with, well, that's just a law. Why is that? What is the difference between a theory and a law? And is one better? Scientific laws and theories have different jobs to do. A scientific law predicts the results of certain initial conditions. It might predict your unborn child's possible hair colors, or how far a baseball travels when launched at a certain angle.
So it's going to be your responsibility to watch all of that. Again, watch all this video. It'll be posted on our announcements, and you need to just simply make a T-chart comparing law versus theory. Okay? Pretty simple at that. Now, oh, oops, not good. Start it over. Okay, let's find where I left off. 1 second, guys. Went to the beginning of the presentation on accident. My bad, my bad. It's my fault. Saw these. Okay. So again, a theory. Oh, well, I'm kind of discussing it here. A theory, again, it's an explanation. It's descriptive. It explains something. Okay. It's going, laws and theories, one is not better than the other. Okay. One is not better than the other. They're just different. They have different roles in science. So go ahead and make sure you write both of these this down. Just put, this is on page, let me see, is this page 6? We're going to put this on page 6. We're going to put this on page 6, law versus theory. Okay. And you're going to see here, you just need to explain the difference. I mean, just the meaning of it, right? So explanation, and it's concept-based. It describes something. What are some examples of topics in science that are theory-based? Evolution, right? The Big Bang Theory, cell theory, atomic theory, okay? You'll notice these are theories because they're to be explained. They're to be described. Laws are different, okay? Now we have laws. The what, remember theory, why, or how. You need to write these down in your notebook, guys. Page 6, page 6. Laws are going to be more like concrete. They're math-based. So anything in science that is math and equation-based is going to be a law. Anything that is like description-based, like evolution, I can't put that in a math equation, right? Cell theory, the Big Bang Theory, I can't necessarily put those topics, atomic, put those topics in a math equation. I have to describe them. Gravity, thermodynamics, laws of motion, those are all math-based. Those are going to be laws, okay? So laws, theories can change, make slight changes, but laws are pretty much concrete. But laws are not better than theories, okay? So go ahead and make sure you have written those down. That concludes our lesson for today. Guys, again, if you have any questions, let me know on Campus Messenger, or leave contact my Google Voice number. And don't forget, we've got the Facebook profile activity online that is due Friday, and you will have the syllabus assignments that will be due on syllabus assignments that will be due next Friday. This is Mr. Campbell. Have a wonderful day. Take care, and I will be signing out.